this should be recording. Yeah, I see my stop button up there, so it should be recording. Okay, so a couple of variations that I did just in terms of like thinking through this design. Largely, the end result of these is very much the same as what we prototyped in foam core in terms of sort of the way things are layered together. The only significant differences in terms of the logic of the structure is we were thinking about how do we set a stop point when the pedal gets pressed down. So you can see I just built that into the structure of the physical model, so that it is when it comes down, that's the hard stop down. It also has a hard stop in the up position. None of this is glued together. This is all just kind of like connected with press fit joints right now, pretty loosely. But now it's got sort of natural stops at the end points, and a lot of structure. So if you were continuing, like you get excited in playing this, and you're sort of flooring it in the game. You're not pushing against some really gentle little stop that you're going to break. You've got quite a bit of rigid structure, the internal and the external parts of this. I'll refer back to the model now. Both these inner parts and these outer parts, when this thing goes all the way down, will land. I don't have constraints set up to not let it go any further and go through itself, but that will stop and give a really nice rigid final fully pressed down position. I added this little top plate. We talked about grip being a potential thing we would want to be concerned about with a pedal. For the purposes of what we're doing, this is more cosmetic than functional. We probably aren't going to have a situation where your foot slipping off the pedal is that much of a problem, but it looks cool. There's no reason this thing couldn't turn into something that could be, finished and be a perfectly good prop for a film or any kind of production work you wanted to do. So we can make these things very realistic. Before I finalize this whole thing in terms of construction, I'll probably paint it, and I'll probably paint this a different color, just so we get a really nice contrast through one layer to the next. So I'll show you guys how that's done. It's pretty easy process, but there's some nuances to that process that might be interesting and helpful. Okay, so one other little detail here, or two other details before we go on to another modeling example and kind of continue to develop this. If we look here on the side, these may or may not work well in practice, but I added a couple of basically what would be thought of like an O-ring, like a sort of keeper ring. I just designed these so that if you look at them straight from the side, maybe you can see a little better. These are just basically these kind of cylindrical forms with a little slice here so that these can spring open just a little bit. So these should just be ideally, I've got one or two of them sitting inside that box, but I'm not going to pull them out. Ideally, these would just press on to the whatever we're using as our hinge material, and just stay on because they got a little bit of a spring friction fit. So something like this can work really well without going to more fancy hardware, more complex solutions. These kinds of like spring fit connections are definitely something that you'll have to do a little trial and error on. You can't just like theoretically say, well, I'm offsetting this by this amount, and I know this thing is this springy, it should work. You got to like actually cut it out and see like how does that material actually work in practice with the kerf of the laser cutter, that kind of thing. But they should work fine with a little tweaking. The other thing that I added to this is a little mount inside. Here, let me just hide a couple of components so you can see inside a little more clearly. Let me find my one trick here. I'll just show this right away. I'm often like, when I got a bunch of components stacked up like this, a lot of which are mirrors of one another, to quickly find them in the hierarchy can be challenging. So I might just click on a surface and see, and then that will get a little underline in your view here. So it makes it easier to glance over and see that's what I'm looking for, and I'll just turn off the visibility of that. Same thing with this little top plate. I can spot it there pretty quickly. So I added a little support structure for our sensor that sort of embeds it in the base of this. So that kind of thing is really useful to a useful thing to do. We were trying to figure out some way of like getting our sensor more or less in place with a piece of foam and sort of some tape. You can make these things much more solid with just a little effort and a little bit more designing. All right. Any questions on this guy so far? We'll come back to it as needed if there's more detailed questions. But all right. Well, I thought what I would do then, in terms of a sort of guided lesson today, would actually be to model a display of some sort. So something that we're thinking of, like this is going to function as an indicator of air pressure, fuel level, whatever it might be. By the way, just before we move on from this, we'll be doing the same thing when we go to this next demo. You can look for a lot of existing components like this sensor. I didn't go to the trouble of modeling this sensor because I looked online and someone else had already done it. I would encourage you to use those resources, give credit for those resources when you do so. But definitely no reason to reinvent those kind of things if they already exist. It's a good practice to model those things yourself, but definitely not necessary. And you can accelerate your work quite a bit by not doing that. One thing though, double check to make sure the scale is correct. So when you bring it into your modeling environment, you want to do an assessment right away and make sure it actually matches the thing that you think it is. Most of the time it probably will be, or it would have kind of gotten flagged by the community and someone would have said, hey, this doesn't work. But don't rely on that. There is a tool in your environment called Inspect, and this is basically just a measuring tool you can use at any time. So I'll just give one quick example of a measurement. If I just come down here and click on the top ring of this sensor, it'll give me a bunch of information about it, where it's at, length, radius, that kind of thing, diameter. So I can double check this. I can say, okay, this says 15.8 millimeters, take my calipers and go measure the real thing that I've got. Take a couple measurements. If those look right, chances are it's going to work. Really critical things for this are often like where are the screw holes? If it's got holes for mounting something, where are those located? So look for those. Make sure those are accurately positioned in the models that you're using, because that lets me set up something like this little frame that's resting in. All right. So let's jump on to a new design. I think what I'll do. Let me think. Where did we leave off? We just started this demo. Yeah. Let me just start another one. So we'll do a new design. Again, first thing, save our file. Let's call this DisplayDemo01. Save. Okay. Next thing I want to do, you could do this in either order, either create your components or set up your parameters for the material you're going to work with. So again, these are like global variables. So click Change Parameters. That was under Modify, Change Parameters. And just click this little plus button to add a user parameter. Right now there's no model parameters because there's nothing modeled yet. So I'm just going to call this, I'm going to stay consistent with what I did last time. I'm going to say EIGTH material. So the material that we commonly call 1/8 inch MDF, which is like what this is cut out of. I'm just going to double check my measurement on that, and we'll enter that, and that becomes a variable we can use. So I'm seeing 2.93, or sorry, 2.996. Take a couple measurements, 2.97, 2.98. It's pretty consistent. This one's measuring 3 at that point. I'm trying to think if I have any good general advice for sort of rounding. It depends a little bit on the software you're using for doing your cutting, how important that might be. I'm just going to put this in at 2.94. Now, anytime I want to use that material thickness, I can just enter that name instead of entering a number. One immediate bit of advice I'll give you: if you're doing something that doesn't require the extra structural integrity of a thicker material, use this 1/8 inch material instead. It's going to cut much faster. It's going to be a lot less painful when you're going to the laser cutters. Our laser cutters are needing a little bit of maintenance. Hopefully we'll get those sort of like tuned up a little bit better. It was pretty slow to get these cut out, and they still didn't cut out super cleanly. So that's something that hopefully will get working a little better, but the 1/8 inch material worked just fine. It's going to be an easier one to work with for now. So for most of what we're doing, this will be perfectly adequate. We also have some clear acrylic, and maybe might have a few colored acrylic materials we can use as well for getting some more like things you want light to shine through, or you want a surface of a screen. So we might model something like that too. I'm going to put in here another arbitrary dimension for because I don't have a sheet with me, but I'm going to put in another dimension and say this is going to be the thickness of a little acrylic or something. So add one more parameter. I'll just call it acrylic, and I'm just going to, for the moment, just say 1.5 millimeters. Okay, so now I could use that as well. You specify that. So yeah, that's a great question though. So if you go to your document settings, this is again in this hierarchical view, document settings. This is going to get more information as you're building out your model, but units is always going to be there. If you want to change your units, you can just click on this thing where it says change active units. You can change it to whatever is appropriate for what you're designing. I would say that if we're designing things that we're going to be fabricating, it probably makes sense to work in millimeters. If we're designing things like a vehicle or something that's going to be in our scene, I might shift that to centimeters. But this is still going to let us operate mostly in whole numbers. As being as consistent as we can, especially things that are going to go into the game engine, is going to be helpful so that we aren't having things that are 10 times out of scale with something else that we intended to work together. So I would say for anything bigger in the game engine environment, work in centimeters and work in millimeters for these. But yeah, in those parameters, and you can always go back and edit these anytime, and they will in real time affect your model if you use them in your model. You can change these things. So there, I can specify and I can change that unit if I need to. So there's a drop down for that. And there's lots more types of measurements. This one is showing a length right now, but all kinds of variables are available in that if you create a new parameter. All right, so let's think about this display for a second. First thing I might be thinking about is one of the requirements again is for this display to have a physically actuated component. So how are we going to move that component? What's an easy way to do some mechanical movement? Anyone have suggestions, ideas? Servo motor, yeah, servo motor or stepper motor. Servo motor is definitely going to be your easiest solution, and it's probably going to be a best choice for most of this we're doing right now. Very few connectors required, no special drivers or anything required. Yeah.
I don't know if a reminder, but do you need to record these in Zoom?
I'm recording in QuickTime.
Okay.
Yeah, thanks for double checking.
Our display, do you mean like our physical setup with all the monitors?
Yeah, what I mean is like you're in the vehicle, like you get in your car and you see your speed, you see control center for your entertainment system.
Maybe we can have like LEDs that light up to point where the speed is at.
We can definitely incorporate LEDs, and I definitely think LEDs are great, but those would be in addition to a physical movement, at least for this first set of these. It doesn't mean everything has to have that, but for this first problem that I want you to address, if you're doing a display, I want it to have a physical, like analog movement of a needle or turning a cylinder, whatever it might be. So let's do this first. Before we go any further, let's bring in a model of a servo motor. So I'm going to go over to my data panel. I don't have a servo sitting in this project, so I'm going to go back a step to my home and just go ahead and do a search for servo. Hit enter, let it think about it. And I'm going to find a bunch of servos, I'm sure, because I've done things with servos and a lot of examples over lots of time. This one here, SG90 micro servo, 9 gram. This is probably pretty close to. I think this is the same servo that came in your little sensor actuator kit. So let's go ahead and add this to our model. So anything you've got, any components you have, you can insert those into your design. Just right click and say insert into current design. You have to have saved that design first before this operation is allowed, but it is now, so. And I'm not going to worry about orientation yet. I can move it around later, but now I've got something that looks like a servo. I can start to use this as I know I've got this pivot point, and I know this is one example of a type of a horn that can attach to something that I want to turn and move. So there's a bunch of different ways you might design a display. I'm going to go with probably one of the most straightforward, simple approaches first, which is going to be, let's think about this just moving a needle indicator kind of a thing. So let's go ahead and orient this so that it's a front view in that way like we want it. So one of the things you'll do a lot is just move things around. So again, I'm right-clicking in anywhere in open space here to do this operation. This is, rather than just going to all the drop-down menus for things, I'm just going and right-clicking, and there's a bunch of quick menu things. So move, copy. and I want to tell it that I want to move a component. This might default to bodies or faces, other things. Tell it I want to move a component in this case, and I'm gonna go ahead and click on. I can click on it in my hierarchy, or I can click on it in my model view here. I'll just click on it here, and now I'm getting a dialog to be able to rotate this thing around. For some reason, the pivot point is way out here. I don't really care about that right now, so I'll just turn that around to 90 degrees. I can see that right now I am facing, this is facing the back. I probably want that to be facing the front. So I use this, when I'm navigating in this, I use this little control widget quite a bit. I would just say experiment with this. Basically, if I click on these various arrows, it's going to flip to various orientations. That's a really nice way of being able to sort of move things around. And I'm just going to rotate this whole thing. It's kind of weird, just sweeping it around like that. Rotate it around 180 degrees. I don't care that it's not at any central origin. I just want to get a general positioning of it. So I'll just move this around again, look at C. Does this look like I want it? And I think it does. So if I look at my front view, I'm seeing the front of it like that. That looks great. One thing you want to pay attention to? Yes, please. Oh yeah, you won't see these models. These are not. There are 0 models sort of available. Well, that's not true. There are some lessons, tutorial things. They have a few models if you dig into those. But yeah, I downloaded this. I will make this available to you. In fact, I'll make it available to you right now so that it's super easy for you to jump and use. Let me just say okay on this. So let me go back to what I was going to say, and then I'll address that. It's a great question. So you'll see whenever you're moving something around, you'll often be presented with the option of capturing a position. That basically means that this is trying to keep track of like where do you want things to be placed at any given time. So if I move something around and I just temporarily did that to get it out of the way or try something out, think through something, then I might not want to capture that position because I might want it to go back to where it was before. But if I'm moving something with the intent that it stays there, this is a good starting point. It's just to say capture position, say okay, now it's going to be here, and if I move it around, I can go back to that. So watch as I do this really quick. Well, so I can see this thing has a bunch of stuff that's independent. Oh, I see. It's got a stack of these different horns on here. How convenient. So whoever modeled this one happens to be one that I did not model. Whoever modeled it modeled 3 different horns for the servo, and those are all independent. And none of these things are anchored together. So we'll do something with that here in a second so that we don't end up with headaches around that. But you'll see up here in the corner where it says position, it's got capture position if I want to keep this, and it's got revert position. So if I want to put all that stuff back where I found it, hit revert position, and it all goes back. So one quick thing we can do here, we might want to make one of these horns into something that rotates around for us. So I think I will do that. I'll leave that out of the equation for a second. I'm going to do that by going in here, and I'm just going to turn off the visibility of that top horn, and I'm going to select everything else and turn it into what's called a rigid group. This will just make this stuff in a very simple way just behave as if it's one single body. So I'll just select everything that's visible there and go to construct. Oops, sorry, not construct, assemble. I usually do most of these things with keyboard shortcuts, so I sometimes forget where they actually hang out. So assemble, and in this case, we want to just create a rigid group. And now all this stuff, we got 6 selected, we'll say okay. It's got the option of including child components. This means like something is a subcomponent of something you've selected. So I'll just say okay. Now if I move this thing around, it all moves as a unit. I can revert, leave it, put it back where it was. But this other one here, this is still independent. And this is probably a good time to demo one other quick thing that's useful in your modeling. Slightly more advanced thing, but it's as good a time as any to give a little preview of this idea. I'm going to turn off the visibility of these other couple of horns that are on here, just so it's not confusing. This one. Okay, so now we're down to this much of this. What I'm going to do is I'm going to create a joint between this horn and excuse me, and the servo. Now in practice, of course, this is going to be fastened into here. What's actually turning is going to be an internal movement of the servo parts, but we're just going to keep it really simple, and we're going to make this revolve on some sort of one of these central axis points here. So I am going to go to assemble, and I'm just going to create a joint. And now I'm going to sort of revolve around here, look for kind of a central point where I want this thing to fit and revolve around. And you'll notice that I'm getting this little representation of a selection and an origin point. I can do that with all sorts of different surfaces. Notice now that origin point is floating out there in space somewhere different. I can do one over here. There's all sorts of different ways I could make origins in various locations. But this one ought to be perfect for this. So I'll click that. And notice that gets grayed out, so I can't make any more selections on that one because that's the thing, that's already one of the components that can be positioned. And I'll just kind of zoom in here and select this as another potential position. And if I did things right, it'll go into place like that. And right now, it's probably going to default. If I look at my motion, it's going to default to rigid. I can tell it that I want it to be a revolute, so it can revolve. If this didn't automatically find the right axis, you can go in here and modify the rotational axis of it. And there's all sorts of ways that can be tuned and tweaked. But now I've got something that when I get ready to look at this and see how is my thing working, whoop, another good important thing to demo here. Let me revert my position. Notice I tried to move my horn, but everything moved with it. That's because nothing is anchored in place. Right now, everything here can move. Since this servo is kind of the hub of this project, I want to tell that thing never to move. So to do that, I will find, let me find that thing. So this is my servo here. I'm going to say, yeah, and I don't want to lock everything in place. I still want to be able to move this. So I want to find like this body, and that happens to be this part of this. It's labeled in kind of an ambiguous sort of way. But if I right-click on that, I have the option to say ground. Say, you're grounded. You're not leaving the house. You're in so much trouble. So now, this can't move. I can't click and drag that around, but I can revolve this. So this gives me a nice way to simulate what's going on with my system. Okay. So we've got a servo motor, we've got a horn for it that we can move around. Probably the next thing that we would want to model, or we could model, would be what is our little indicator? What are we actually visually going to see? We don't want to see the horn as our pointer. We want something that's more of a modeled thing. So let's make a quick pointer for this system. So now, this is the other thing you should be remembering. We can collapse these things so that we have less visual clutter over here. You can also close out this. Before I get too far away from it, I promised I was going to share this servo with you. I am sure if you do a search, you can actually find this and download it from Tinkercad or one of those locations. But this is another place I can show you just a way to share something. So I will go ahead and right-click on that and just say Share Link. So I'm going to be asking you as part of some of these assignments to share a link. They call this a public link. So we'll just turn on, click where it says share the latest version with everyone using this link. And so I will go ahead and allow it to be downloaded, make sure that's selected. Don't require a password in this case. So I'll just copy that. And let me jump over to, I have no idea what's going to be open here. Okay, so class search. Find the right physical computing and jump over here, interface prototypes assignment. Let me just drop this link in here. I'll just call this references, even though it could be a bunch of things. Let me do better than that. Let's call this, this is the servo model. Whoop. External link, come on. So this will give you a link to, this will take you to Fusion 360 where you can download this in various ways. Let's actually take a look at what that leads to, just so you've got, so you know what your options are there. And we'll see how fast it is available on here. It should be right away. Might take a second for it to figure out what to show, but here it is. And I probably should upload one that I've modeled here, but it's kind of internal for what we're doing. And so under download, you're going to see there's a whole bunch of different things you could use. I would recommend going ahead in this case and just download the Fusion 360 archive. This will give you essentially something you can import directly into Fusion 360, and it'll be one-to-one, like everything's going to be the same. For different things, one of the things you'll see a lot that's really useful are going to be step files. You can download step files for a bunch of different 3D things, and they will maintain this hierarchical view. They won't have joints. They won't have a lot of the features that will be a full Fusion 360 file. But so I'll show one other quick thing related to that. Let me go back to my Digital Physical Systems Fall 23. If I wanted to add something like that, I would just go here to upload, navigate to where that's at, and then click upload. That's how you get that into your into Fusion 360. Cool. All right. So this is being recorded, so you can review if you didn't follow any of that. All right. So on to modeling modeling a little indicator for this. Let's go ahead and create a new component. So like we brought this in, it's a new component. So that's great. Let's go ahead and create another new component. Just right-clicking that top level, give it a meaningful name like I'll just call it my pointer. Say OK. It is automatically activated. You can see it's the active component. It's got the little radio button that's filled in there. So now I will create a sketch so that I can start to make a drawing of whatever it is that I want to turn into a 3D thing. And it's asking, what plane do you want to draw on? Since I know I want this thing to be attached directly to my servo horn, selecting the servo horn as a foundation is a great way to start this. It says in this case, some component positions have changed. I must have dragged something. So I want to go ahead and say revert position so that it starts out wherever I left it intentionally. Great. And let's just square things up again. Oh, I have this kind of sitting at a weird angle. I'm trying to decide how much I care. I think I care enough that I want to correct that first. This is going to be a little disorienting in terms of how things are going to align. Is it just that? No, it's this whole thing. Let me fix that first. Let me undo create sketch. So this is not sitting quite straight up and down. That really doesn't matter. We're going to be moving it anyway, so we'll just leave it where it's at there. But let's go ahead and orient this so that this is at least sitting straight up and down. I just think for sanity's sake, as we do the rest of our modeling, this is going to be smarter. So under modify, we have the option of aligning something to something else. So I will just say align, if I can find it here, align. And I'm going to align like the side of this thing. If I can find a solid flat surface, so like this. And in this case, I want to actually align it to my, not a named view, to my one of my origin planes. So I need to turn these on so I can see them. Then I can rotate around here, and I will select. I think I have to select it from this. This is going to be a ZY plane, or YZ plane. Come on. Should let me do this. No, I may have to. I thought I'd done this before, but maybe not. Let me just do a really quick workaround. I certainly recall using this as a way to align before, but it doesn't seem like it wants to. Oh, I know why it won't. Anyone know what the problem is? What did we tell this component? We said you're grounded. Yeah, so we need to unground it first. That's the problem. So let's find that. It's in here. It's got a little pin in it that shows that it's grounded. You can ground as many components as you need. So let's unground, and then we'll do that operation again. We'll do that alignment. So modify, align, take this surface here, and align it to this plane. There we go. Now this should be, and I'll capture that position, say okay. Now when I look at this straight on, yeah, now it's sitting like I want it to. That is good. I think, yeah, I'm not going to worry about the alignment. Do I want to worry? Yeah, I'll just square up this this horn, just roughly. It doesn't have to be. Whoops! I need to reground that so I can move my horn independently. Now that we've got it lined up again. Now I'm just going to square this up because it'll be easier to work if this is more or less pointing straight up. Doesn't have to be perfect in this case, but we'll get it more or less going upright. I feel like we're out of alignment in another orientation, but I guess it's okay. Just a bit of a perspective thing. Okay, so I'll capture that. All right, so back to our pointer. Let's turn off that origin view so it's not distracting us. Let's close out that extra viewer. And we'll just create a sketch on that servo horn. That looks much better. And then we can just start to rough out some kind of a shape that we like as a pointer. This can be as simple or as elaborate as you want it to be. I think I'll start with a circle just because that becomes a nice sort of base for it. I'm going to type C for circle, but you can come up here, select it from any of the drop-down menu options. Getting to know the keyboard shortcuts will really help you out. You'll notice a lot of these things, because there's existing geometry in the horn that will correspond to this. I can snap to a center point. That's really great. So I'm just going to make a circle, and I'm just looking at how big is this? How does it relate to that horn? I'll go ahead and type in and make it 20 millimeter diameter. And then I'm going to go ahead and create a couple of lines. I'll do a line from here first. Yeah, I'll just do a straight line. I was thinking of doing a spline, but let's keep it simple for now. So something that comes up like this. And I'm going to hit escape just to get away from that for now. I'm going to create another kind of a line. So I'll type L for line. And I am just going to create what's called a center line. This is just going to be a line that will not define any actual 3D geometry, but it's great for saying I want something that is symmetrical. Okay, there we go, 90 degrees. So if it didn't want to snap to 90 degrees, I was going to have to go and type in that number. But now I've got this center point. I'm going to go ahead and create another one more line here that just connects over to here. You'll notice when I did that, this starts to, you can start to see where this could sort of be, this can start to become 3D geometry. Things are starting to kind of fill in. I've left a lot of things undefined in terms of dimensions. If your sketches are still in blue, it means things are not sufficiently fully defined to sort of lock them into place. It's better to have things really locked into place with dimensions and angles and all this. But for some of this, it's not that critical. It won't matter that much. And sometimes you want to leave that undefined for a while so that you can actually sort of drag things around and set them up as you wish as you start to see your forms develop. So what I can do with this center line now is I can create a mirror image. So under create, I'll select mirror. I'll select this line, and this line, and you can see it automatically, since I created that line, this is the logical mirror line for it. If that didn't select by default, you could go ahead and select whatever line was the appropriate mirror line. But I'll say OK. And I think let's do one more thing here. I'm just thinking about how this is actually going to get modeled and how I'll actually assemble it. I can use some little screws or even hot glue this to a servo horn, but I want to make sure that I leave this opening exposed for this screw. And actually, it looks like because of the way what I've got for geometry that's already in the plane of that horn that we are sketching on, I've already got a circle right where I want it. So that's fine. I've got enough geometry here to create the 3D form. So I'll just finish my sketch and I will do an extrusion. So extrusions over here. I almost always just use type E for extrusion, but if you want to go find it over here, we could also do a revolve if that was the more appropriate thing. You can see what kind of shape that could make from a profile. But extrusion is like one of your simplest and most commonly used ways of creating. So I will start selecting any of the parts of this that I need to make the shape that I'm looking for to actually turn into a 3D thing. So it's basically all of that. I'm going to go ahead and just leave all the little holes that line up with that horn. Again, hopefully the horn that you have in your model is going to match what you actually have physically. If it's not, you can remake that. And then I just want to tell it how far out to extrude to turn this into a three-dimensional thing. Here's the first point where we actually want to use one of our variables that we created. So if you remember, we created a variable called 1/8 inch material, or 1/8 material. I'll just start typing E for 1/8, and it will automatically fill in that. So now the distance it's extruding, shows over here, it corresponds to that variable. And it's creating a new body in this case. So I'll just say OK. And now I've got something that lines up with that horn. So in terms of your pattern of operations, sketching, extruding, or revolving or something like that to create your 3D thing, very next thing that I would be thinking about, remember we created a new component called the pointer. Right now, that is going to move around freely. It's going to do whatever it wants to do. I want it to move with my servo horn, right? So what should I do now? Yeah, I should attach my pointer to my servo horn, and I can do that by creating another joint. There's a special type of joint that I can do that makes this really simple. And again, you'll get in the habit of this. If you're modeling things in place, then you can use this really quick operation. So go to Assemble, and we will just do what's called an as-built joint. So it's already in place exactly where we want it. So we click as-built joint. I select the pointer, and I select that servo horn, and make, in this case, the type of motion is just going to be rigid. I want them to stick together. Say OK. Now I've got something I can move my pointer where I want it. All right. OK, so we've got the start of an indicator here. Let's go ahead and think about how are we going to attach this thing to. How do we start to frame this out so that it becomes an indicator, not just a pointer attached to a servo? We would want to start to think about, like, okay, maybe making kind of a box form for this all to exist in. So what I would probably start with would be creating kind of a back plane that this thing will be seen in relation to. And I'll do that. Again, we'll make a new component. Let's go ahead and minimize that one again. And so right click, create a new component. Let's call this the, I'll just call this back plate. Okay. And if I look at how this thing goes together, probably the nicest thing would be to go ahead and put that plane so that it comes off of one of these little tabs that your servo can attach to things to. So we'll do that. I'll create a sketch. Make sure you're working on the right object, the right component. I'll just go ahead and select this one, and I will go ahead and revert position. I moved that horn around while I was working. And now you can see I've got this, but things are kind of in the way. So I want to turn off the visibility of a couple of these things so I can see what I'm doing. Turn off that pointer, and I'll turn off the visibility of that horn that's out front here. I think that's this one here. There we go. So now I can see what I'm doing here. Okay, so I've already got this geometry in my sketch. This is another thing you'll do repeatedly, and it's really, really quick and easy to add information that helps me align things right away. And this is called projection. So if we go to create and project/include, say project, I will go ahead and project other really important geometry. And really there's only one other thing that's probably going to give me the important foundation of this, and that's this other little planar surface right down here. So this is going to have a projection link. That means if that other thing changes, this will change with it. Just say OK. Now I can start to just make a little box around this thing, and that'll give me something to create this initial plane with. So I could do this in a variety of ways. I think the nicest thing would be to say, I want to start and be able to make this on a center so that I don't have to go back and realign it later. So I'll just go ahead and make myself a center line as my first operation. So L for line, go over here. This is a sketch palette, by the way. This has a bunch of different things you can be selecting. I'm just showing you some of the more common operations. So make it a center line. And I just want to come into my model here and look for where this is going to snap to a center. If you look really closely, you can see a little triangle appears. That triangle says that I'm at the center of something. And essentially that's the center between this point over here, where that curve starts, and this one over here. So that ends up being my perfect center. So I'll just click that as a starting point and just come straight down. I can drag a little bit further if I want to drag this out. Maybe I'll go ahead and just go down to the bottom of this for now. I just care that this is straight up and down for, and that's all that I really care about. So now I can go and I can make myself a rectangle. So I typed R for rectangle, but I want to create not this default, what they call 2-point rectangle, but a center rectangle. This just means a rectangle that I define starting at a center point. And I just want to drop my center point somewhere on that line, that center line I created. So I'll come down here and I just click and drag out, and I can start to make a shape. And I don't know how big I want this to be yet. I'm just kind of like making a general shape. And you'll notice now, because nothing is sized yet, it is the only thing that's sort of locked into place is that thing is sitting on the center. If I hit escape and I just have my regular cursor here, I can start to drag things around. So I can just sort of size this thing, start to look. I might bring my pointer back into the display and say, oh, well, okay, obviously I need a little more space for this thing to move. So maybe I want something that goes up here, and notice that because it's symmetrical, that was expanding together. This one probably doesn't need to be down that far. Just needs to be something like that. We'll start with that. That's pretty good. That's going to give me, is that going to be wide enough? Maybe not quite wide enough. Let's go a little bit wider. Something like that. And just say OK. Now I can just extrude this. E for extrude, select that. I probably want to go in and select these extra little bits here. What I can see right away is that I'm going to have to go back in and kind of, I'm going to do a little bit of sort of some manual, other manual operations to put a hole in the right place for that to mount to. But let's just start with this. Let's go ahead and extrude this thing out so that it gets thickness. What thickness do you think I want to make that sheet of material? Yep, that's basically, this whole thing can be out of that 1/8 inch material, so we'll just use that again.
The acrylic material made, does this be like the paint that's on it, or what is that acrylic? 'Cause you made like two.
I made a dimension for like a clear acrylic, and I just guessed at some dimension for that in case we want to drop it in here. So okay, so we got something like this. So now, basically, I've just got something that can be attached into the back of here. But if we look at this thing, if we get rid of this for a second, you can see this is really just a solid sheet. It doesn't have any geometry that corresponds to that thing sticking through it. So here's a really neat trick you can do. This is really very, very useful. I want to say, oh, I should hit save here, by the way. I haven't saved this whole time. You should save periodically. You get in the habit of doing this sometimes because so many things automatically save anymore. And this to some degree does, but I don't want to rely on it. I want to have some versions. I should give this a meaningful description of what we've done. We've created servo, added pointer, and backplate. Just so we can have a reference to come back to if we need to go back to this version. Okay, so here's what we're going to do. We're going to cut a hole in this backplate using this geometry that already exists as a cutting tool, basically. And we'll see. I don't know how this thing's modeled, how well this is going to work, but this will give us a good starting point anyway. So under modify, you've got this operation called combine. This basically gives us Boolean operations for managing 3D components in relation to each other. So we'll say combine. So first thing it asks for is a target body. This is the thing you want to change. So we want to cut a hole in that sheet. So let's say that's our target. Then it will say, what tools do you want to use? In this case, I'm going to select the body of that servo as my tool. I've already got this set so that it's selecting a cut operation. You could be doing a join or what's called an intersection. But in this case, cut is exactly what we want to do. And you can see it's giving us a little preview of what it's going to be cutting out. In this case, we want to keep the tool. We don't want to delete or hide our servo. We want it to be maintained. So we'll say keep tools. Just say OK. Now, if we turn off the visibility of that servo, you can see we've got a hole in there that corresponds to where that servo is. If you are laser cutting something and you know your dimensions of like that servo were very accurate, this will probably be a pretty good fit. You can probably just push this thing on there and everything fits nicely. That's great. If you're doing something, maybe you're 3D printing or something, you may need to add some additional tolerance to this, make that hole a little bigger. But for now, this is a really easy way to do it. I could have just sketched that out and just sort of like put in all that geometry into the initial sketch, but this is a really handy way to do it. Let's go ahead and do one other critical thing. Remember, we don't have the holes yet for where we're going to fasten this thing in. So let's go ahead and make another sketch on the surface of this and then just project where those holes need to go. So create a new sketch, select that plane. Let's hide our pointer again so it's out of the way. And we'll do that projection operation. Again, this is P for project. And then I can revolve this thing around. This is the easiest way for me to find what I want to see for geometry. I might want to hide those little screws that are in there. That way I can see what I'm trying to match. So I'll come in here and grab this little arc. This is not a complete circle, but it'll give me an important reference point. You can see in red, right up sort of parallel to that, it's showing that's where it's going to project onto my sketch. Just like that. And I'll do the same thing, or go down here to the bottom and get this other one down here. Now I say okay. Now I can use those projections to draw my circles in the right spot so that I've got a place to make those holes. So let me go ahead and get that out of the way and come back around here. So we're looking at this from the front. So now I can just draw a circle, and I can start at that origin because it knows this is a circular arc, so it automatically gives me a center point on that. I can draw a circle, and I could just snap it right to the dimension of that. Or if I say, well, let me give myself a little more clearance on that, I can make it a little bigger. So I can just kind of look and say, well, let's just make this, let's make it 2.5 millimeters. So 2.5, like that. And I'll do the same thing up here. Another C for circle. And I'm not going to dimension this one yet. I'm going to show another quick trick that you can use. So this is anything I haven't dimensioned while I'm sketching it. If I just hit D while I'm in the sketch environment, it's D for dimension. And now I can go over, click on various things, and drag out a little dimension. So I could obviously just type 2.5 here again, but I know I want these to be the same size. So I can come down here, click on another existing dimension, and you see it says now D dimension 12. So if I just hit enter, it will show that that is 2.5 millimeters, but it's got fx in front of it. That means a function is generating it. So now if I go back for any reason and I change the dimension of this one, if I make that, I'll just make it 3 for the moment. This will also become 3.
Does that work both ways, or is it just for the second one? Like if you reset the second one's dimension, would it change the first one?
I can't, yeah. So if I try to manually go in here, you can see it's just going to be a reference to that original dimension.
Okay.
So I could go in here if I wanted to say, I don't want those to be linked anymore. I could go type another dimension here, but no, you'll break the association between them. So, good question. So I'm just going to finish this sketch. That's all I need to do. I'll leave them at 3. That I don't care about the extra 0.5 millimeter. So now the E for extrude, select those two little circles. This is something, you can just drag this. Notice if I drag my extrusion one way, it's making posts. If I drag the other way, it starts to cut. You can define what you want the operation to be here, but that's how it's going to behave by default. And I can just drag that all the way through so I can see that it's visually cutting through it. But I can also, I'll do this a lot, especially if I know that this dimension of this thing might change later on. Rather than relying on okay, that's through this, I will instead of saying extent type being distance, I will make this to an object. And then I can select that plane that I want it to cut to. And so if that ever changes for any reason, that will always update with it. All right. So we've got, let's go back. By the way, anytime you want to get back to a sort of a default orientation of things, you can click on one of these things, but even better, there's a little home button that'll sort of reorient to whatever you have established as your home view. Let's go ahead and turn back on our pointer, turn back on our servo, and we can see that this thing's starting to make sense. Okay, so we created this thing, but it's not anchored yet, right? So let's go ahead, before we get too far down the road, let's revert that position. And you will see, let's go ahead and make this joint first, and then we'll do one more thing. So we just want a rigid joint between that back plate and the servo, just like it's going to get fastened together in real life. So assemble. And again, we can just do as built joint since we built it in place. Select that, select that. It's rigid, say okay. So we're good. If you're watching closely in this browser hierarchical view, you can see we've got two different joints here now. So we've got our there's actually another joint that's in here, but it's actually I think it's in the servo itself. We'll come back to that one in a second. I think it's a really good idea as you're creating joints to name them. Everything's going to look like the same thing. They're just going to say rigid or revolute or whatever they are as you're building them. So go in and just double click and name these things so that you tell yourself what do these connect to. So that was just the back plate and the servo. And this one, if you don't know what it was, you can right click it and say animate joint. And this will basically show, in this case, since it's a rigid connection, it's just going to shake it around and show that that thing is rigidly connected to this other thing, which in this case is the servo. So hit escape to stop that. And something is not, somehow we moved something and misaligned that. I'm not sure what we did or when we did that. We'll fix that because that's going to be a problem. Things won't line up right, and it may or may not matter depending on how much of an error this is, but it can matter. So let's go ahead and name that one first. Let's call it pointer and servo. Those things are, oh, that's not, hold on, that's a rigid joint, isn't it? What is that connecting to? Oh, this is, okay. This is not pointer and servo, this is pointer and horn. We just have our horn hidden. Our horn is somewhere hiding out in our servo. I don't remember which one it is. It's not that one. It's not that one. It's that one. Now it's lined up. But good to keep an eye on those things. So now everything should be coming together. This thing I can't move because it's anchored. It has a joint, rigid joint to something that is grounded. But those can still move independently. So we're starting to get something that we can start to think of as sort of a little again, an indicator of whatever it might be. Let's revert that for a second. So now, just to frame this out, let's go ahead and make a front plate for this that covers everything we don't want to see from our front view. So to start and do something like that, I can see we're out of time. Let me show this really fast. If you've got a moment, if you can start getting packed up if you need to. But let me show this last thing because it'll be helpful, and we'll pick this up again on Tuesday. You guys should be starting on these models for whatever components you're making for sure. But let me show this. I'm going to create what's called an offset plane. Rather than working on some existing plane, I'm going to create what's called an offset plane. There's a bunch of different ways you can create reference geometry. So offset plane is one of the most simple. I will select this plane that is this back plate and then just offset it by whatever distance makes sense. So I can look at this thing from the side and say, okay, I want that plane to be just in front of my indicator by a little bit. So maybe I'll go ahead and make it, I can change this later if I want to, but for now, let's make it 18 millimeters. Okay, so now that gives me a reference for this next component that I'm going to do. It would have been smart maybe for me to make my new component first, make that offset plane in that new component, but it doesn't matter too much. So now I can make a new component. I'll do this kind of quickly. We'll call this front plate. Create a sketch on that new plane that we created. Do a projection of this back plane. Let's create a window inside it. So let's do a center line first. See, this actually goes, once you kind of know what to do, this actually can go pretty fast if you're not trying to talk and describe each step you're doing. So we'll do a rectangle. We'll do a center rectangle. Just come in here, just snap to that center line, start to draw out a window here, and go in and customize that window until it gives you the visual view that you want for your indicator. And say extrude. Find all the surfaces that need to be extruded. Do this in the 1/8 inch thickness again. Say okay. And now we're starting to get something that this is not a bad looking little. Oh, we're out of fuel. We got charged up again. Great. All right, cool. All right, we'll finish this design out. I might actually finish this design. I'll end this recording now so we don't risk losing this recording. But I may finish out this design, continue recording just like I'm doing now, so that you can use it as a reference to be working on these. There's just a couple more techniques that are pretty straightforward but really practical for building out something like this. Then we'll talk about how you take this 3D geometry, turn it into things you can laser cut. All right, thank you guys.